Okay, so this part, since your work is going to be mostly on the theoretical model, not the experiment, so we will also have to, inside your literature review, we will also have to find in who has done like solar desalination, solar steel, solar distiller in theory. Okay, maybe I give a quick search in sciencedirect.com. So you can see in Science Direct, modeling and simulation, improving the design modeling simulation of a solar steel, modeling simulation of the continuous production. So there are plenty of the simulation CFD model. Okay, these things are plenty of, like for numerical simulation of pyramid solar steel also have. Okay, but the thing is, what type of software do you use? Like, do you use ANSYS Fluent or COMSOL, any type of simulation software you have been using?
Actually, my laptop had broken, and now I work with my brother laptop,
Understand.
and uh,
Okay.
he can't progress with
Understand.
access
Understand.
with
Understand.
answers. So we
Uh,
worked with SolidWorks.
SolidWorks. Okay. SolidWorks is will help you to develop the design, but for calculation, okay. Then how about Hamza? Do you have any type of, like, you used previously anything like ANSYS Fluent or COMSOL or anything? Because I think COMSOL you can have like online COMSOL multiphysics, but I'm not sure whether they will give you the student license.
And the
Yes, Hamza, if your line is not good, you can just type in the chat.
doctor,
Yes. If it is not possible for you to use the software, uh, we will just go through the analytical model. Okay? We'll just go through the analytical model. Uh, this one, they use, or some people use transit. So
you
someone
can
has,
try to use the SolidWorks.
but SolidWorks doesn't have the heat transfer model, right? We can develop the design of drawing of the thing in SolidWorks, but it doesn't have the
I
heat transfer model.
I I made a heat exchanger with SolidWorks.
Huh?
I made a
But
simulation for it.
simulation for the heat exchanger, right? So could you find like how much heat was transferred from one to another? Calculate.
Yeah,
You
yeah, it's calculated.
okay, okay. So you can use SolidWorks now.
Yeah, I can use it.
You can use it. Okay, then we just keep the SolidWorks as one option. But if not possible, like to use simulation software or maybe your computer is giving you problem, then we will go back to the original equations, right? So any of this paper, you'll find the equations they have used, a thermodynamic review on solar stills. This one will be quite good.
Yeah, we can try to calculate it and writing the correlation and work
Uh-huh.
theoretical.
Yes, yes. So we will stop after we have developed a model for the part one of this project. Okay, so this one, like it has thermodynamic review, so it will give you a very good insight. Maybe I'll just upload it in your WhatsApp. So they have actually covered all sort of solar steel, right? This one is the spherical, hemispherical, pyramid. This one is a tube, multi-stage. This one is a multi-stage one. This one with the fin.
Hamza wrote something for you
Yes. Okay, let me check.
in the chat.
Okay. Before I go to the chat, I just want to show you this thermal performance of solar steel. In any case, we cannot run the simulation. We will be going back to the traditional equations. Okay?
The old way.
Right. Yeah, this one. In any case, we cannot access the simulation software. We will use this old method of solving the analytical model. Okay. Okay. And this one is going to be
Okay.
the end of your work for this semester. Now let me check what is ANSYS program, but it requires high. Yes, yes, yeah. That's a problem with ANSYS. I don't know. Okay. Okay, fine. No problem. No problem. If you can go with solid, we try with SolidWorks, but in any case, we see that SolidWorks is not enough. We can always go back to the old school method of analyzing and solving it. No problem. No problem with that. Now, so after we have done this, we always close the literature review by the last part will be the research gap that we have identified through literature review, like what work hasn't been done in Gaza, because your one is located in Gaza, right? So you can, it will be quite well written. It will be, you'll have enough thing to write there. So Gaza, I don't think I have any solar steel report from Gaza yet. So you can say that this is going to be your first solar steel design in Gaza. If you can search for any solar steel studied in Gaza will be good. You can compare with that. And from there, you can also offer some upgraded design. Okay, so research gap is always the very crucial thing. This one is to close the literature review section. That means I have studied all these things, then I have identified the gap, like still what is there left for me to do? Still, what new can I do? What new things can I do on this project? So we close the literature review section with the research gap, and our model development, the theoretical model, the equation used, all these things will be inside this literature review. Then we will complete here for F final year project FYP part 1. Then part 2 will start in next semester. There we will try to either solve analytically or we do it through the software, and we try to produce the result, right? Say for example, you just design a solar steel in your SolidWorks, then you can run the simulation fine. You run for different hours of sunlight, different season in Gaza, different season, how much should be the expected production rate. And then we have to validate, right? Say, for example, if you are saying that, okay, with my designed solar steel, I'm getting like 20 liters of water per day. I'm not going to accept it because it is quite impossible to get 20 liters of water from any solar steel. Okay, so that's why we need to check whether our simulation is correct or no. So we will go to our objective number 4. So this one is to design a numerical optimized solar desalination system. I think only Saad Mohana is here. So did you get it that we are going to get all this number 1, number 2, number 3 in details? All will be uh, like the literature review will help us to decide on these objective. And then in the next semester, when we go for our chapter 3, 4, results and discussion, we will evaluate the performance of the design solar steel against published data. So we will see, okay, we have done this numerical simulation on the solar steel. Then we compare it with the published solar steel data. So I believe from Egypt, they have like many solar steel research, many from Egypt. So I believe Egypt and Gaza weather is, I mean, they have kind of similarity, right?
Yeah, we're our neighborhood.
Yeah, yeah. So more or less same, but maybe Gaza is near the sea, so the weather is more moist, like humidity is higher. Egypt may be a bit dry. So never mind, it's okay. We actually try to compare it with the nearby area, the Egypt, Jordan, if they have, so we can also take help from here. Solar desalination, Egypt. Under Egypt weather conditions. So there are some papers, right? Not this one is not PVRO. We are not doing it. So we do have some, if not Egypt, we can have Jordan also. We can try Jordan also. Solar steel, Egypt.
This
Under,
for comparing the data, yeah?
yes, like after you have done all your things, it is not yet validated until we can show that in the similar zone, similar area or zone, they have a similar experimental output. By improving the performance of solar steel by using PCM as a thermal storage medium under Egyptian condition. So we just click it, although it's an old paper, maybe we can also check for the recent ones if possible. If no, old one is also okay. So this one you can see that it could produce a very good, highly sophisticated made with a phase change material. It could produce daily freshwater productivity approximately reached 7.5 liter per meter square in a day for solar steel with PCM, while its value is recorded 4.5 liter per meter square per day for conventional. So we are now designing for the conventional solar steel. It doesn't have any phase change material or anything. We are just starting to do. Then we will see whether your result coming up is somewhere around 4.5, 5.5, 6.5, 2.5, but not 45, not 50. So these are the things we have to initially check. Then we will be fine tuning our simulation. Okay, so initially it's always good to check initially what is the possible range that I can get from this simulation result. So if you check it initially and then fine tune, or if there is any significant error, then you check at that point, it's a better decision because you submit it with a very high value, then later on it's going to raise concern among everyone that is solar steel is actually it can produce maximum up to 7 to 8 liter in one day per 1 meter square of solar steel area. But if from your simulation, initially there will be many things going wrong in simulation. Whenever you do the simulation initially, there will be many things going wrong. So we will compare it and check it, and then we will fine tune. Is that okay?
Yeah, it's okay.
Okay. So maybe I just go to see whether they have put in the Egypt solar data, right? So they have put in solar desalination. The radiation, you can see it can go up to like, uh, which one is the solar irradiation? I believe this one, right? So it can go up to like 1,100 approximately. This one also somewhere between 1,500. The very high solar irradiation around 12 p.m. Uh, that so it's starts from 6 a.m. in the morning, 7, 8, 9, 10, 11, 12, around 12 p.m. it is highest. Then it starts to drop. And this one is what day? In June, right? So so they did it in July, almost same. Uh, they didn't do it beyond June and July, right? So if you can get the Gaza solar irradiation data, is it possible for you to search for Gaza solar irradiation data for the whole year from anywhere?
Try to search for
Okay,
it.
try to search. We can also search in Science Direct. Gaza solar that is already published data is safe to use. So I believe this one I have sent you, right? Esteemed Solar United Arab Emirates. Okay, solar energy potential. Electricity imported and generated. Okay. Palestine electricity is this. Egypt total efficiency and demand. No, I am not getting the solar irradiation. Global. Okay, we have the global irradiation. We have the diffuse. We have the direct. So this website can give you the Gaza solar irradiation. So if we can actually do it for by month to month, Gaza in January, how much your solar steel can produce in February, March, April, May, June, July, August, up until December for 1 year. Total, how much is it possible to produce based on your simulation model? We can also add it up toward the end of your work. So it will be a comprehensive work overall. Okay. So we set our target now that we will be able to complete up until or middle of objective number 3. Objective 1, objective 2, we should be all doing it this semester. Objective number 3, maybe we will at least complete 75% of it. And then in our next semester, we will be doing objective number 4 and remaining objective number 3. Is that clear?
Yeah, it's clear.
Okay. So we set our target like this. Then anything you need any more explanation, let me know. Anything you didn't understand or you need further explanation. I have recorded
It's
the meeting. Then after I download I will upload it in either Moodle, or maybe if size I can downsize it, I'll just straight away upload it in WhatsApp. By the way, I'm just asking, uh, do you want your quiz too for the solar engineering, solar energy course to be done like the way we did it previously online, or you want me to upload the question and then you will answer and then you upload the PDF copy is better for you?
PDF or model. Yeah, PDF best.
Because I think last time when we ran the quiz,
Both is good.
yeah, many students face this issue of internet, right?
Actually, yeah, all of us.
Yeah, understand. So it's better that I do not run the live quiz anymore. Okay. So I'll be uploading the question of the quiz. Then you download it. Then maybe I give you like 1 hour, 2 hour time. You write the answers, then you up scan and upload it in the uh, thing again, right? In Moodle again, right? Or you can just send me in WhatsApp, whatever you find is easier.
Actually, you are free.
Yeah, good, good.
We can ask the all
Okay,
to
okay. Now
take a decision about.
I'm just asking your opinion because I received feedback from one student that they didn't have the internet at that time, so they had to go to the canteen area to get the internet to answer the questions. And someone's cable actually came out, so he couldn't finish the thing. So I was thinking maybe rather than running the live quiz, I'll be giving you the time-based assignment. Okay? I'll ask the class
Okay.
also.
Okay.
I'll ask the class also. Maybe I'll put it as a poll. So then I take the majorities option. But if you are doing like that time-based assignment, then the question definitely will be quite tough compared to what it was in the live quiz. Okay. So we decided this. Maybe I now